Okay, two particles. That's, of course, you have to expect that the AP test will be different than anything you've practiced. They always find ways to make it feel different. But if you go really, really slow, it starts to feel the same. So two particles, two is different. Two particles move along the x-axis. A particle moving along the x-axis is not new. I have the origin here. Usually I'm just used to one particle moving back and forth along the x-axis. Now I have two. Time period is 0 to 8. Position of particle P at time t is given by this formula. That's how I would find where particle P is located. The velocity of particle Q, oh, be careful here, don't read fast. Position of particle P. So this is position of particle P. Now I've got velocity of particle Q. Don't read fast. That's velocity of particle Q. The position of particle Q at time 0 is 5. So I would write the position of particle Q at time equals 0 is 5. Okay, find the acceleration of particle Q at time equal 2. Stop right there. They've asked me to do something. I always want to get points as soon as I can get them. So I have the velocity of particle Q. So if I take the derivative of the velocity of particle Q, that will give me the acceleration of particle Q. Now, you can use your calculator on any problem on the test this year, but I really strongly believe, well, okay, back up. They also said, though, that you don't have to have a calculator. Therefore, I think it's best to practice solving these problems without a calculator, because they're going to design problems where you actually don't have to have a calculator. So I'm going to do this one without my calculator. This derivative is rather quick. 2t minus 8. I don't know if they'll make it that simple, but that one was. So I just want to find the acceleration at time 2. So acceleration of particle Q at time equal 2 is going to equal 2 times 2, subtract 8. That's negative 4. No units are given in this problem. So I have found the acceleration of particle Q at time equal 2. Now I keep reading. They gave me 1 point for doing that. So continue reading. Is the speed, not the velocity, not the acceleration, the speed of particle Q increasing or decreasing? Now remember this box from the golden notes, and also remember doing this on previous practice tests. So I need to go find, see, I found the acceleration. I need the velocity at time 2 for particle Q. So I say the velocity of particle Q at time equal 2 is going to equal, plug in the 2 squared, remember I'm using this formula up here, minus 8 times 2 plus 15. So that's going to equal 4 minus 16 plus 15. These combine to make negative 1. So I just think of it as adding. It's 4 plus a negative 16 plus a positive 15, which is the same thing as 4 added to a negative 3. So that's going to equal 1. So the velocity at time 2 is 1. The acceleration at time 2 is negative 4. Strong function there. So my answer is right here. It helps if I don't make a mistake somewhere. What did I do wrong? Okay, here's the mistake. Negative 16 plus 15 would be 1, so this should have been 3. Good thing I don't have to get all the points on the AP test to get a 5. Bad joke. So that's why I wrote up here, the velocity at time 2 is 3, the acceleration at time 2 is negative 4. Since the acceleration at time 2 and the velocity at time 2 have opposite signs, the speed is decreasing at time equal 2. The points awarded on this one were 1 point again for finding the acceleration correctly, 1 point for having this box here with your answer and explanation.